There's a lot going on this time of year at the Idaho State House. Committee meetings, bill proposals, and key debates that could shape Idaho's future. I'm James Dawson, state government reporter for Boise State Public Radio, and I spend my days from January to April sorting through the action at the legislature so you don't have to. Sign up for my weekly newsletter, Legislative Roundup, and you'll get each week's biggest news and developments from the session delivered straight to your inbox every Monday morning. Sign up for Legislative Roundup at our website, boisestatepublicradio.org.
From the studios of Boise State Public Radio News, I'm Samantha Wright, filling in for Gemma Gaudette. It's Idaho Matters. What do you think of when you think of extraterrestrial life? Little green men? Microbes on Mars? Anything in between? Dr. Rachel Smith is an observational astronomer who is searching for extraterrestrial life by studying the scientific processes of our universe. She's the head of the Astronomy and Astrophysics Research Lab and the curator of meteorites at the North Carolina Museum of Natural Sciences. And she's the feature speaker tomorrow at First Friday Astronomy, courtesy of the Boise State Department of Physics, who does it every first Friday of the month. She's with me in studio today to give us a preview of her talk. Hi, Rachel. How are you?
Hi, I'm great. Thanks for having me.
Oh, this is going to be great. Okay, what kind of extraterrestrial life are you looking for?
So I am actually not searching for life itself. What I study are the systems of stars that are forming today before planets form. So my research focuses on the chemistry before the planets form and focusing on the organic chemistry that will go into forming planets like Earth and the molecules needed for life. So we have to understand these processes before we can really understand the inventory of Earth-like planets out there and really know where to look and listen for life. So that's my research really focuses on that early chemistry, trying to also understand our own solar system and how it formed.
Well, and I think it's fascinating because you have to look at that chemistry of the early solar system. Tell me how you do that. How do you actually study that?
I use big telescopes. So the largest ground-based telescopes that we have on Earth are the ones that I'm focusing on now. And specifically, I'm using the NASA Infrared Telescope Facility on Mauna Kea in Hawaii. And it has an amazing instrument, a spectrograph that's termed iShell. And this spectrograph enables us to get really amazing lines of carbon monoxide, which is what I'm focusing on. So that's carbon and oxygen. And we need carbon and oxygen to form planets like our own and for those molecules for life to form. So I'm looking at these stars where they're still surrounded by these disks, these giant disks of gas and dust, just like our solar system had about 4.5 billion years ago, to really try to understand those chemical pathways. And there are not many telescopes that can do this with the kind of precision we need to try to answer these big questions about how does the chemistry work? How did Earth form? What can we learn from meteorites as well by comparing to these stars? So that's what I use. I go to Mauna Kea in Hawaii to do these observations.
Let's talk about meteorites. For anybody who doesn't know, what is a meteorite?
Yeah, a meteorite is a piece of rock that comes usually from the asteroid belt. We have very few meteorites from Mars and the Moon. They come from the asteroid belt. When they land on Earth, they're called meteorites. So they're pieces of asteroids that hit planets and moons. And so we have lots of meteorites on Earth in collections like our own at the North Carolina Museum of Natural Sciences and in many other collections. And these are our oldest material that we have in hand from our own solar system. So they're extremely valuable for science, and they're really fascinating to look at. And actually, I did bring a meteorite with me from North Carolina, a piece of iron, which is super robust. And so people can come see it at the talk tomorrow.
Oh, cool. You can actually look at a meteorite.
Oh, you can touch it too. A piece of iron's really hard. It's the only type of iron that we have from a planet is from meteorites because we can't sample our own Earth's core. So when we have meteoritic iron, I like to bring it out to show people because it's really hard to break that stuff. You can handle it a little bit, and it's a little chunk of iron, and it's the only what's fascinating is that we still can't sample our own Earth's core. It's too deep and down inside the Earth. So the only planetary iron, actual iron that's made from a planet, is from failed planets from the asteroid belt.
Wow, that is amazing. Okay, so I love this idea that you're looking at meteorites and what's hitting the Earth to find out how the universe was formed, how planets are formed. I think that's great that you can actually sort of look backwards that way.
Yeah, you could absolutely. Looking back in time is fascinating and also a really important challenge to recognize. So when I teach this, I talk to my students about it, especially. I tell we're looking back in time. That's especially true with astrophysics. We're absolutely looking back in time through space to these great distances. And meteorites are these relics from way back billions of years ago. They don't really tell us about the universe, but they do tell us about the solar system. The universe is far older, 13.8 billion years old, so we have to look much farther for that, looking at the cosmic microwave background and shifting galaxies, which is not what I do. But we are looking back in time, and so that to me is so fascinating. But we may never have these answers, and we may never know exactly how life started on Earth, how exactly our solar system came to be, but we're really trying to piece these puzzles together.
I love it. We're speaking with Dr. Rachel Smith. She's the head of the Astronomy and Astrophysics Research Lab and the curator of meteorites at the North Carolina Museum of Natural Sciences. She's giving a talk tomorrow night at Boise State titled From New Stars to the Edge of the Universe, The Search for Extraterrestrial Life and Our Cosmic Origins. And apparently you can actually touch a meteorite if you go to the talk. I understand you're a big fan of open space. Mm-hmm. You use it a lot in your talks. What is it, and how does it help science?
Yeah, thanks for mentioning. So Open Space is this software that I'm part of a project that's led by the American Museum of Natural History in New York City, and our museum is one of the funded partners on this project. It's funded by NASA, and we're in year 10. And what it is Fly Through the Universe software, and it's all data-driven. It's state-of-the-art visualizations, and I have information on this as well to pass out at the talk if people come. And they can also go to the website, openspaceproject.com, to learn about it. It's absolutely free, so you can download it, and you can fly through the universe. You can go to planets and moons. And I love using it in talks to really puts the Earth and our solar system in a context that people don't usually see when you just focus on the planet itself. So we're going to start on Earth. We'll look at some of the data sets of the exoplanets. We'll fly out to the end of the universe, and I will bring in my research as well as where we're searching for life in our solar system, and then the search for extraterrestrial intelligence, which really takes us beyond the solar system into the deep space universe.
And anybody can use open space.
Yes.
And you can set it up so you can just look at asteroids or just look at...
Oh, yes. You can turn data sets on and off. I'll have the asteroids to talk about. So it's really great software for anyone to use. It's still in a process of development. So I would just say that it probably requires more of a gaming type of a computer, but there are lots of gamers out there if you like that. And so check out the website and see if you're able to download it. And also there's tutorials. There's all sorts of stuff there. So I'm excited to show it to everyone.
It's really, really cool. Okay, you mentioned looking outside of the universe and looking in solar system, and then inside the solar system. So what about inside the solar system? Are we going to find life in our solar system, Mars, Europa, Titan? Yeah,
well, we don't know. If there's life in our solar system, it's likely going to be microbial. So it'll be single-celled. It's not very hospitable out there compared to what we consider a comfortable way of life here on Earth. We have an atmosphere, we have oceans, it's warm. So life in the solar system will be beyond what we call the habitable zone of our solar system. So we have Europa Clippers going out to Europa, and we'll orbit Jupiter and do these flybys of Europa and try to see what makes a habitable world maybe under the ice of Europa. Europa is a really prime candidate because it has this ocean, a global ocean, may have more water than on the entirety of Earth. And if that's true, there might be life in there kept warm by the pull of Jupiter. Mars, of course, we have rovers on Mars. Still no evidence for life, but looking maybe for past life. And also studying how can we send astronauts to Mars eventually. Maybe in the future, and this was probably decades from now, humans will probably attempt to go to Mars. And that'll be a long journey, much harder than going to the moon. And so a lot of these missions to Mars are also testing technology to safely land astronauts. And so our next stop, of course, is the moon again with Artemis 2, and that's exciting and hopefully will happen in the next year or so, sending astronauts again. Since 1972, we haven't been back to the moon to orbit the moon and hopefully land an astronaut in the next few years.
And what about outside the solar system? I know a lot of people are excited about exoplanets. Mm-hmm. Is that a good way to start thinking about maybe there's other life out there?
Well, certainly trying to build this inventory of habitable worlds. Like every star has a zone around it where liquid water can exist on the surface of a planet. And so the farther out we go, the harder it is to know the details, right? Because we have limited technology. So we're really limited on how we're able to explore, especially beyond our own solar system. I mean, we can't even, our farthest mission is Voyager, which is not even past, is going towards the Oort cloud, this big cloud of comets. So we're not even really beyond our own solar system. And that's been going 1 million miles per day since the 1970s. So we have a long way to go. And remote sensing of exoplanets is certainly the cutting edge, trying to understand these atmospheres, see if we can figure out what makes a habitable atmosphere, trying to understand if we can even figure out if we know if there's life on these worlds. And we're really far from doing that yet. We're not quite there yet. So I would say it's going to be difficult, especially to find microbial life on an exoplanet, even know if there's life there. But that's kind of where we think about, if there's extraterrestrial intelligence, meaning beings that can communicate off their own planet like we do, then we might be able to listen for those types of beings if they're out there. And that's going to be very difficult to do. And they may not even be out there anywhere close to us. And so that's kind of the transition and kind of how I think about the search for life is we can look in our own solar system for microbial life. We can look for exoplanets that might be habitable. But then beyond that, we're really not able to journey very far, even remotely. And so we're trying to listen and still SETI, the search for extraterrestrial intelligence, is still going and trying to figure out, can we understand signals from an intelligent civilization? And we're still trying to work that out.
There's a lot there.
Yeah.
And you're going to be talking about a lot of this. What do you tell people to try and get them to come tomorrow night to find out?
To try to get them to come?
Yeah.
Oh, well, certainly come. I would love to see everyone who's interested, anyone interested in space, in the search for life, and understanding Earth's place. How do we think about ourselves in the context of the solar system and life in our universe? And I always bring it back to Earth because these, all the research we do, the research I do on protoplanetary systems, anyone working for SETI or looking at Mars or wherever you're thinking about, that really also tells us about ourselves and tells us how do we fit into this context of a habitable world, the only world we know of with life still in our entire galaxy, let alone universe. And how do we even think about that? And I think about this a lot, and I would love to share that with people to try to see if we can, to try to share this kind of what I think of as a wondrous view of the universe and how we fit in that. And will we ever even go beyond and explore ourselves in a spaceship? Who knows? So I just enjoy sharing these ideas with people, and I hope everyone comes and maybe not everyone. I mean, I don't know how many we fit in the room, but as many who would like.
Well, I think it sounds like great fun. We've been speaking with Dr. Rachel Smith. She's the head of the Astronomy and Astrophysics Research Lab and the curator of meteorites at the North Carolina Museum of Natural Sciences. She's the featured speaker tomorrow at First Friday Astronomy, courtesy of the Boise State Department of Physics. It'll be tomorrow night. She's going to be talking about the search for extraterrestrial life, our cosmic origins, her research, and she's going to have a meteorite you can actually put your hands on. And on Saturday, she's going to be speaking at the Haley Public Library at 5 p.m. And if it's clear, there'll be some stargazing once the sun goes down. Rachel, thanks so much for being here. I really
Thank you for
appreciate
having me. This was so much fun.
You've been listening to Idaho Matters from Boise State Public Radio. I'm Gemma Gaudet.